Okay, well, good morning. My name's David Boyd. I've been doing spectroscopy for several years now with a Shellyak LISA spectrograph, and most of my analysis has been done with ISIS, so that's what I'm going to tell you about today. I'm going to use images which Shellyak provided, taken with an ALPI, because I understand there's many more of you using an ALPI, so I'll use that as an example of how to process with ISIS. First of all, has everybody who wanted to download ISIS managed to do it successfully off the website? That's good. And you've downloaded the data set that comes with it, and you should have the latest version. I see it's actually now got a 5.9.7, but 5.9.6 has been the latest for a while. I wouldn't bother uploading this one. I think that's mainly about new features with a new spectrograph that Christian has been playing with. So you should have 5.9.6 and the ISIS data set database that was released at the same time. And the other thing you might want to download, if you haven't already, is GNU-plot, which runs in conjunction with ISIS to give you plots. If you're going to download it, only download a version up to 4.6, GNU-plot 4.6. If you try a later one, it doesn't work, and I don't know why it doesn't work, but the advice is to stop at 4.6. And you should install, I think for simplicity, install the database and GNU-plot in your C drive directly. Don't bury it too far down the hierarchy. I think it works. I think GNU-plot might not work, actually, unless it's in the C drive directly. So I'll assume that you've got these things set up. A little bit about ISIS, just to understand where ISIS comes from. It's really been developed by Christian Buell personally. Christian Buell is really the brains behind Shellyak and many of the spectrograph designs that are around in Europe at the moment from that company. He wrote ISIS for his own purposes, for processing spectra. It therefore very much is geared to the sort of things he does. That's very good because he does a lot of things. There's a lot of functionality in that, some of which, in fact, quite a small part of which we'll touch on today. But we can answer questions if people are interested in going further. He does occasionally update it and change it. He's developing a new spectrograph, if you've been looking on the internet, called the UVEX. And he's added some things and made some changes in this latest release of ISIS to help process those spectra. So what we're seeing is very much a piece of software that's a work in progress by Christian Buell. Because it's got so much functionality, I think it's a really good place to use. It's quite tricky if you approach it for the very first time, and that's what I'm going to try and get over today, is some of the things that you need to do to set it up so that you can then process with it.
David,
yes.
Just a question. I haven't downloaded GNU-plot.
Right.
That going to be critical?
It won't matter for what we're doing today, but I'll show you in the course of running through it what it does, and you can then decide whether you want to. It just is a back end almost to produce some plots. So with that, what I'll do is start actually looking at ISIS on the screen and show you what you would see. If you load it and set it up, this is the main screen you get. And the first thing you see is along the top there are a lot of tabs. And you think, what on earth am I going to do with all of these? Well, the one you start with and you should look at is settings. This allows you to set up a number of parameters which will be permanent. Once you've set them up, you won't need to change them again. So it's worth spending some time just looking at this and getting it right. The obvious ones, I'll start on the right-hand side here. Can you see, where the mouse is? Obviously English language. Some people I've seen download and get a French version and then say that they can't understand it. I think what you sometimes have to do then is close it down and restart it.
I've got a comment on that, David.
Yes.
I found that if you use a very old Windows, such as Windows Vista, you can't get it to go onto the English version.
Right.
But
okay.
Then I tried Windows 7 and then it did work.
It works, yes.
So it doesn't work on old versions.
Yeah, I know there have been some comments on news groups about that, that's why I mentioned it. These, I think the settings there are the ones that normally come up when you load the program for the first time. Standard. This thing here, spectral profile spectral domain for profile scaling, is a slightly subtle one. Normalization is a process of dealing with spectra where the intensity level of the spectrum is scaled so that it has a value of unity at a particular wavelength. That's strictly speaking what normalization. It's different from rectification, which you sometimes talk about. Rectification is where you basically flatten the continuum level so it's unity everywhere. Normalization is taking the spectrum and simply scaling the profile as it comes to unity at a particular wavelength range. And what these two parameters there do is they define the wavelength range that the spectra produced by ICIS will be normalized to unity in. And it's slightly important because if you're going to use spectra from the Miles library, that's a library of stars with measured spectra, which you can use as reference stars, for example. Most of the stars in the Miles library, which is included in the ICIS database, are normalized to unity in this range. So setting up, and that changed from the previous version to the current version, which was a complication that nobody realized until we actually got it and tried with it.
It's actually a slightly different range.
Sorry?
It's a slightly different range, automatically preset.
Yes, it used to be 6600.
Right, that's about what it is.
Yes.
6630.
Yes.
So you're suggesting this should be the better?
This works better with the most recent version of the ICIS database. Slight catch that we might see in processing. Some of the spectra, Miles standard spectra in the ICIS database are normalized at different wavelength ranges. They all used to be normalized at the same wavelength range in that 6600. When it was redone, which was done to try and improve the quality of the spectra, if anybody wants to know about the Miles library, talk to me after. It's a bit of a story, and I'm not going to go into it now. But I would suggest setting values like that. The point about that small range is it's usually a range that in most spectra there are no features. There are no strong emission or absorption lines. And therefore the continuum is relatively smooth in that area. And therefore taking an average over that and using that to normalize your spectra to unity works reasonably well.
Can I just ask, can the projector be focused better?
I have no idea, unless there's a control for it, or somebody is 20 feet tall. I think we're struggling.
We thought it was our eyes, but
I suspect it's probably as good as it gets, actually. Isn't it? I don't think it's changing much, really.
Whilst we're doing that, is it worthwhile changing those different ones? Should we be typing those different ones into our blank?
Yeah, I would suggest working with those values than the default ones that you've probably got when it downloaded.
Okay, so if we just start to put those...
Yeah.
I'm asked at the front desk, but I'd say carry on for now.
Yeah.
The only thing which looks like it would do it says it's not supported. So
Yeah. I mean, the key thing is if you can see where my pointer is, then you can read it on your own screen, what the values are. Erase automatically intermediate files. You can set that to no, and then you'll get a lot of files left after a processing, which are not particularly useful. So I would suggest setting that to yes. Again, add your observer name to the file name is useful. It's normally left ticked. Up here you can set the spectrograph you've got, and as you might expect, the list in there are the standard Shell-Yak spectrographs plus the star analyzer. I'm not actually going to say anything about the star analyzer today, partly because I've never tried to process star analyzer data with ISIS, but I think John is going to mention that in the afternoon in the BAS session. And I would strongly recommend, if you've got an ALPI and you haven't got the calibration module, you should try and buy one, because it really makes using the ALPI so much easier. So I'm going to assume that we've got a calibration module with it. I'll skip that box for now. Here's where the ISIS database is stored on my machine, and here's where GNU plot is stored on my machine. And down here is the latitude, longitude, and altitude of my observatory. You put yours in there, values in there. These, I think, are the default values. You can make spectra with ISIS look pretty by ticking the rainbow box, and then you'll get a nice color spectrum. For most scientific applications, you don't bother with that. You just have a monochrome spectrum, because it's the profile you're interested in, not the actual spectral image. I've no idea what the right value for the coefficient of cosmetic ray filter is. I don't know what default you got when you loaded yours. The one that the field that you will change every time you use it is this one up here, the working directory. This is where I currently have the example files that I'm going to use today. So that's the settings tab. Are you happy with that? No questions? Okay. The next one that you really, images just for displaying images, and one comment I'll make here is that ISIS does not display 16-bit images well, because it truncates at 32767 bits. It doesn't go up to 65. So I wouldn't use this particularly for looking at images. They don't look pretty, but it's just there. For example, if I display a flat file, you'll see that it's just totally saturated in large parts of it. Okay, so General tab is really the next useful one, and I'll just mention. Oh, sorry.
Just briefly, we can't find a way of focusing at the moment, so if there's a break at some point, we'll take a look. But is everyone okay with kind of reading?
Yeah.
I think it's kind of the letters. So thank you.
Yeah. Start down here in the bottom right-hand corner, file name, prefix, and suffix. ISIS has a particular requirement for how you give it file names, and that is that they are all ending in serial number, like 1, 2, 3, 4, 5, 6, 10, 11, 12, whatever. You have the option here of setting the object suffix is currently set to a little dash in that box, and that means it's assuming file names will be, say, object name -1, object name -2. So one problem you might have is, depending on your image capture software, you have to, if you're, say, supposing the file names comes out as -001, -002, -010, you've got to find a way of turning those all into the ISIS assumed sequence of file names. There is actually a tool for doing that in rename. Under MISC rename, I've never actually used it because I've found my own way of doing this, but that might be a way worth exploring if you're faced with an image capture package that produces numbers that ISIS directly you can't use. I actually use a PowerShell function with 2 lines in it, which will go right through my folder and rename all my files to that sequence. I can show you that maybe over the lunch break if anybody's interested in it. But there are ways of doing that, but it is a requirement of ISIS that it's expecting files to come in that with that sort of naming structure. And one other thing is you can adopt a convention that your calibration files, that's files taken with the calibration lamp, will have some name in there before the dash. I've historically used underscore neon dash, simply because when I started, all you had was a neon calibration lamp. You've now got argon neon calibration lamps. If anybody's still using an LP with an old, I don't know if the LP ever came out with a neon lamp, but I would strongly recommend upgrading it to the argon neon, because it's got lines all the way through to the blue part of the spectrum, which the neon lamps doesn't have. But that's historically why I use that. You can use whatever you want there. for if you want to. It just means whenever I take a calibration frame of, say, if it was Vega, I would call it Vega _ neon dash. Whereas up here, the actual image files would be Vega dash. So that's the file name. These output parameters here are things that will get written into your FITS file headers. FITS file header, you can have whatever you want in there. That's just what I've got. It tells you what equipment. Anybody picking this file up years in the future will be able to see from that what I used to record it, where I recorded it, and who I am. The R box there gets filled in by ISIS automatically. It's the resolution that it's calculated for your spectrum, and that will go in the FITS header, and you've no control over that. It's a quirky thing of ISIS. You have several modes of doing spectral calibration here. I now exclusively use file mode, and what that involves is giving ISIS a list of wavelengths. In fact, I'll show you what that file looks like. That is my Alpi Argon Neon 14. There are 14 lines in it. The first, I can give you copies of this if you want it. The first line is the order of the polynomial that's going to fit across the whole chip. 3.4 is a figure for the dispersion in angstroms per pixel. I had to adjust that because I haven't used the Alpi before. When I was setting this up, I had to adjust that in order to give me a good fit. It's slightly bigger than I thought. If you actually process Alpi spectra with this, it will tells you that the dispersion is 3.1 angstroms per pixel. I find this calibration works better with 3.4. That could be because this is a linear interpolation. The actual fit is a fourth order polynomial. And these are the lines. You can find the wavelengths of these lines in any of the standard things like the NIST element spectral line lists. But I can give you a copy of this file if you want. But if you start with this file to calibrate your spectrum, it works well. This is the range of bright lines in the argon neon lamp that you get with an Alpi. There is unfortunately nothing bright to the blue end of 4158, and the red end is usually truncated by the edge of the chip at 7272. That's the reddest line that will fit on the chip that we are seeing here, which is I think was probably an ATIC 414. If you have the chip, the bigger Sony chip, 694, you can get an extra line in the red on there, but that's just why these lines are what they are. Okay.
I have used a 3.9
right, good.
line, but it is sort of
it's a mushy sort of line. Yeah, if it works, it works. Yeah.
But maybe not automatically.
Well, I don't know. There are consequences of the limits of that list, which will come to when I talk about spectral processing. So that was the.
What's the advantage of that over the predefined LP calibration?
Sorry, say that again. I didn't catch.
What's the advantage of that over the predefined mode? Because I found the predefined mode works fine. So
Fine, good.
Yeah.
Use it. If you like it, I would use it.
I just wondered if there's some reason why you.
I don't know.
Yeah.
They're used the very early days because they only had a neon calibration lamp. You used to calibrate using red lines from neon, and then by taking a bright A-type star and using the hydrogen Balmer lines in that, and a sort of combination of those. And some of these modes were more attuned for doing it that way. It was a clunky way, and it really wasn't very satisfactory. Because if the star you're observing happened to have radial velocity, it screwed it up. So using the file mode is, I think, the most consistent way of doing it. But there are many options in ISIS for doing calibrations, and experiment with them would be my suggestion.
Okay.
If you want to see, and if you can get better results, that's fine. So that's that. The other parameter that you would need to know is the pixel size of your CCD camera. Again, for this particular camera, which is a Sony ICX 085, I think it's CCD, the pixel size is 6.45. With the bigger Sony chip, it's 4.54. So it's important to get that number right, because the calibration don't work if you don't.
Is it all right to bin pixels?
It is. It could work, and you have to. You have to.
You do, yeah. You have to double it.
Yeah,
Yeah.
you have to double that number if you're going to bin. I'm thinking, yeah.
And
For
then you still have to adjust it a bit from
Yeah.
the double bit is.
if you're trying to optimize your fit, it's worth playing with the decimal points of that number. You could adjust it to 6.44, 6.46. Sometimes that just improves the quality of the fit. It's not obvious why that should be, because the chips are made exactly to that size. They're all the same. But the way your optics and everything else which are involved in that produces the spectrum, sometimes it's worth tweaking that number just a little bit if you're not happy with the fit you get.
One question there.
Yeah.
That R value, the resultant value, under output, that is not a variable.
It is not.
A variable, that just
It's-
pops out each time you do it.
ISIS calculates the value, doesn't tell you how it does it. I can tell you how it does it because I found out from Christian. And it's just a number. It's actually based on lines in the red part of the spectrum, which were in the neon bulb originally when he used it. It's indicative. And you can actually control the resolution your spectrograph gives depending on how you focus it.
So the variable to play with to get calibration to run smoothly is that pixel size. That's the
Yeah, that I wouldn't encourage playing with it, but only if you're really not happy with your resolution and you think you could do better. It should be better than it is. That may be a parameter to play with, to try. And the other thing I normally leave, all of these are unticked, except optimal binning. The recommendation I've heard is that it's best to leave that ticked. What that involves is when you take a spectrum, which runs along the X direction of your camera, you put a band around that, above and below it, and you combine all the pixels at 1x in Y to produce the value of the intensity of the spectrum at that value of X. Optimal binning is a clever algorithm for how it does that. And it's built into ISIS, and I'm told it produces a better result if you use it ticked. I've always done and not had a problem. I've no idea what rejection coefficient is. I think that's might be to do with noise. Anyway, I don't know what it is, so I won't tell you. These boxes I'm leaving blank at the moment because we'll fill those in as we process. These are the boxes into which you put names of files that you're going to use. And a set of files, offset, dark, and flat, which are calibration files. And that's the next thing I'm going to show how to create. Happy to move on? Yep. That's the Masters tab. This is the place within ISIS where you calculate your calibration files that you're going to use. And now we'll start with the offset image. This is what's often called a bias. It's an offset that's set in the camera to ensure that all pixel values are positive. You normally just have to subtract it. And I'll go back to this set of example files from the Alpi, which I think Andy sent you around information on how you can find them. I will, if you scroll down that list, you'll find there's a bunch of files, offset, 0 seconds, blah, 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 -1, -2, -3, -4. These are the files that I'm going to use to calculate the mean offset, an average off. It'll be a median average of all of these offset files. So what I have to do is pick up the name of the file. Okay. Do I need the dash? I can't remember. We'll find out in a minute. Take a copy, go back to ours, and drop it in here. Generic name. I think I'll need a dash on the end of that. Image number 15. If it works when this... Yeah. Okay. It's found there are 15 of those files, which we could see on the listing. When I hit go, it goes through them all, calculates the median of them, and puts it into the file called offset, which I've set there. We're going to do the same with darks. Now, what ISIS does is when it processes a dark image, it takes the offset off all of them. So the dark frame is now a frame which is basically centered on 0, plus or minus relative to 0. So if I go back to find the darks in here, here's the darks. Let's take the...
Obviously, you have to have your working directory correctly set at this point. Give me 30 seconds.
Well done, thank you. Yeah, please chip in when I forget to tell you things.
Yeah, because otherwise you're going to...
If you go to settings, you go to settings,
Yes.
that's where you have to put the directory name of the directory that you're going to pull these files from. If you don't have that in there, it won't file them, and you'll get a message in French saying
There's an error on the road for such and such.
did not file, did not find it, not unknown, inconnu. So
Sorry, Dave, can I just ask, do people have the calibration list file in their unpacked?
no,
Oh.
I can give you that. I'll put it on a memory stick and pass it round, and everybody can take a copy of it. I think you can get them online. People, they've been posted, but I'll just give you it today. It'll be easier. So we're going back to masters. So I'm now going to put the generic name for the darks in there. Need the dash. We got the dash. Okay. If you click on that blue box, it tells you there's 11, so it's worked all that out. And now if I hit go, it's now going to process all the darks. I've called it Dart 180 because the files were 180 second exposures. They were 3-minute exposures, dark exposure.
David, just to be clear, the image number is a manual setting. You tell
No,
how many images
the image number is something it fills in.
It fills in based on what you can find.
Yeah, if you click that box, grey box beside image number, it will work out how many it sees. And if it doesn't see the number that you know are there, you've probably got the name wrong.
Yeah.
Yeah.
I see now.
Yeah.
So you have to click the grey box to populate that box.
You have to populate that box, and then it says, okay, I've found 11 darks, I will process them. The normal trick with darks is you take your dark image with an exposure which is as long as any of the spectral images you're going to take are. Normally, I don't record images longer than 5 minutes, so my darks are 300 second darks. Because what ISIS will do is, when you take an image that, say, has only 100 second exposures, it reads that off the FITS header, it says, the intensity of this is only 1/3 of the standard. It does a correction for the dark frame. All of that is built in. These are the clever things that Christian has put in to make it easy to use. You don't have to have different darks for every exposure you do. Just take one which is as long as the longest exposure you use that as your dark, and the rest just happens magically.
How do you load the offset?
Sorry?
How do you load the offset?
The offset you create up here, at the top left. That's the offset file that you've made at that stage. You put that name in there, the same name that you wrote here, you put in there, and it reads that offset file as part of the process of creating this dark. And similarly up here, you put the dark file name that you've just created down here, up there. Now, you have to decide what cosmetic files are basically hot pixel files. They're files which contain a list of known hot pixels on the CCD. Sorry, right, stop.
So I've run the computer dark image, but it's not populated that result with any name.
the result name you give it. That's your choice of name. You have to tell it a file name that you want it to put that merge dark into.
Put a name there before you run code.
Yes. You give it the name you give it the name that you want it to put the result in, because that's your choice of name. That's your convention for naming your dark file, master dark file.
It was blank, but it's still right.
Right.
Okay, but anyway.
That's a cheat, because I had run. Yeah, I should have blanked these off. Let me do this. I'll just very quickly run through this again. That's how it starts. They're all blank.
Yeah. Because this is, honestly, Dave, this bit is so important.
Yes.
Everyone to understand.
I know. Keep asking the questions. That's how it works. Yeah.
And just tell us where the present place the working directory is. I think at the raw spectra.
Sorry?
The Francois spectra, where should we put that file?
All the spectra I'm using are in a folder called ISIS Data Reduction, which Andy told you where you could download it. I think it was from Dropbox.
And where should we keep it?
Sorry?
Should we have it in an ISIS file or on C drive?
You can have it wherever you want it. It doesn't matter where you put it, as long as you tell ISIS where it is. Okay? Okay.
I wanted to pick up these ones okay. So let's process these all right. But whatever I put in for the dark...
You want the dark in there.
I need dark in here.
You need dark in there, yeah.
Oh, okay.
Yeah, if you copy that in there, it will... Yeah.
In capital D, what does it matter?
Sorry?
Capital D.
Doesn't... Well, no. You see what's up there on the screen? In that box is the name of the sequence of dark files that were in the folder. That we...
Yeah, I'm putting the sequence in the wrong place.
Yeah. Ah, right. No, that's fine. And then you have to put... And then you put a name in there. Well, you've got to give it a name. In the orange box, you have to give it a name for the dark file that you want it to create. See, I've called it Dart 180. You can call it anything you like. But in the orange box. That box. That's your name that you're going to use for the master dark that you're creating. You can call it, just call it dark if you want, it doesn't matter. Problems?
Only when I get up to here.
Right. Tick the grey box.
I'm new to all of this, so.
I found 11 of them. Okay, now hit go. Now it's processing. It's working its way through the file. You can see what's going on in the box here. And when it gets to 11, it will stop processing. A lot of this is in French, unfortunately. And it's now stored as the combined dart. Master dart as dart 180. You now want to put that same name up here, exactly the same.
No hyphen.
No hyphen.
And then do go there.
And then I'll tell you what comes next, because the next bit's a bit subtle.
And then I'm up to where you've got.
Yeah, you're up to where we've got. Are we ready to go on? No. Yep. You have to get things right. Yeah. But the beauty is, once you get it right, it just works. Yeah. Okay. Are we ready to go again? Are people happy to move on to the next stage? No? Right. Let me come round.
I'm just struggling finding where this, I don't know why it is, but when I click on here, it only gives me an option of going via this OneDrive or something.
Ooh.
I've got my files set on this desktop. That's just where I've got them.
Yeah.
All the right things. And then, sorry, I've also got it in French, which is the other problem. But,
yes.
I've got this set up in the right place here in configuration. I think that's just, well, that's what I think. I've got, where I want to go for configuration is taken to a slightly different place. I don't have another choice to go to, I don't think. I want to go to the desktop. It goes to my desktop via this OneDrive, it seems to, when I choose it. So I can see this here, when I click that, it's okay.
Yeah.
I don't know if that's what the problem is, but now when I go to here, I've got all these put in the correct place, but when I click go, it doesn't do anything. It just tells
No.
me
Can you store those files in a folder somewhere on your machine?
Well, that's what, yes,
Right.
here it is.
Yeah.
But maybe I put it on my USB stick, that might be a thing to do.
Or just on your C drive?
Well,
Yeah.
that's what I'm trying to do.
Oh, right.
What is the route? Can you hover over that? What is that for?
Hello. We're stuck here because
Go to settings. So you've got that's where the files are, is it? That's correct. Okay. So go to masters. Right. So click the grey box there, and nothing's happening.
that's a problem. And I've got this to work before. No,
Yes.
I just,
The hyphen at the end.
yes.
Yeah, you need the hyphen.
So, do you think my file name is too long or something?
No, the file name's not file name.
I'm sorry, I've just switched it off now. This is the
You having the same problem?
No, I've got to compute, and what I found was that it needed what you browse through and you got to a file name. I found you had to include the entire file name,
Yes.
including -1, and it doesn't report the root at all, just the
Oh, you're ahead of me here.
Okay.
You shouldn't be using that for what we're doing. Just stick in masters at the moment.
Well, I am in master.
Yes.
And I'm stuck in a generic offset name, and that seems to work.
Yes.
Darks as well.
Yep.
For the cosmetic file, that's the one which takes out bad pixels and stuff, isn't it? Okay, so I need another.
I've not got to that stage, but what you're going to type in that box is that name there, Dart 180.
Okay.
Because you're going to process that file that you've just made.
I've just renamed it to see if that makes any difference. Call it LP Spectra then.
Right.
Show me the files actually in there. They're not under anything else under there, are they?
They're all in one folder.
This is another folder.
Yeah.
Another folder.
That's where they all are.
Yeah.
So that's the folder that you should.
Yeah, sure. I'll say it's a folder inside a folder. So.
Yeah. If you go back to your directory listing.
Yeah.
If you.
Hang on, I'm just trying to find it again. Here we are.
The way I get this is if you click on that box there.
Which one?
The one that's got the folder name in it. Up. That one there.
Yeah.
Click on that. Right. Ooh. No.
Got a box inside a box, haven't I, somehow?
No, that's fine. Go back to where you go.
You show me.
Is this? Sorry, I've lost. Right. That's where it is. Is that right?
No.
Where? It's in this one.
Yeah.
Okay. Open that. Click up with there. Copy that into the settings.
Okay.
The box in the settings tab.
Yeah.
So if I do a Control C, which is a copy, where's ISIS?
It's gone up now. I'll switch it off, but I'll see it again.
Yeah. If you bring ISIS back up.
Yeah. Okay.
And then paste that into the box in the settings tab.
Yes.
It should then find it. Try doing that now and see.
Okay. You see, now what's strange is that's a file inside a file, isn't it? You see what I mean? Okay. Yeah.
That just. No, click on to the right of that in the blank space. That's and then copy that into your settings tab. Yeah.
Okay, I don't know why.
Yeah.
Thank you.
So I shouldn't be doing the cosmetic file yet?
Not yet.
It'll work itself out from the darks, I think.
Yes.
Yeah.
Okay. So if you fire up ISIS again.
So I'm waiting for it.
Yeah. Go to settings and paste into that. Right. Now go back to masters and click on the grey box. Yep. Yeah, you're off. It's found them.
Thank you very much.
That's
just
okay.
a file name. I'm sorry.
Is everybody happy?
Getting there now, I've got the database which I wasn't informed about.
Right. Oh.
So very kindly
Yes.
transferred it across.
What are you doing?
It's just the file naming convention.
Yes, it's weird, but
Yeah.
once you get your mind round it, it's
Yes, and you've only got to really do it the first time.
yes. Yeah.
You know, so
Once you get the hang of it, it's straightforward. It just
This is a bit I get stuck with every time.
yeah. Okay.
I'm in French because I reinstalled the latest version.
just come out and go back in. Remember? Yeah, just
close it and start up again.
Just close it.
Yeah, close it. Yeah.
Close it.
Start up.
Right.
And start it up again.
And restart it again.
And it should come back in English.
Yeah. Yeah, we've got it. So you know, you always use that dispersion file. You always use your own dispersion file.
Oh, the wavelengths file, the .lsd file. Yes, I always use mine. That one.
Right, because I'm lazy, I just use the Alpi.
Yes.
And it works. Now I want to use the L200.
Yes.
I'll have to get my own dispersion file for the L200.
Yes, but it might well be the same file. Oh, it's a list of wavelengths.
Of course it is. The only thing that changes is the dispersion.
Yes,
number.
That number is the thing you have to get right.
Yeah, okay, yes.
And when I did this for the first time, so I've never used a set of Alpi data before, I had to play with that number until it converged and gave me a decent fit. Right.
It's a Relco.
Yes.
That's got no neon in it.
Right.
It gives you, it's packed with argon.
Yes.
Fabulous blue ends.
Right. What about the red end?
Really, I mean, all the way up to 7.
Oh, right. Oh, brilliant.
So I don't know, that's from a Relco, I got that by mistake. I'll show you the calibration frame for it. But you can't get that. It's more appropriate. I just thought I'd mention it.
Yeah.
It's obviously things that
You've discovered something useful here.
And it's also, and I couldn't believe it. Sorry, I didn't know. It's also got a very strong gamma lens in it as well.
Oh, so there's hydrogen in there too. Yeah.
Bass is much easier to use, much more
Okay.
I'll show you a frame here. That's it.
Yeah. Can we move on now, do you think?
I think so.
Yeah.
I've given some files to someone there, but it may be worth moving on now anyway. I think.
Yes.
Is that okay?
Okay. Can we move on now? And I will show you how to compute what they call a cosmetic file, which is really a file of hot pixels. This is very useful because every camera will record a whole bunch of hot pixels, and you want to be able to take these out. This is the way I do it. There's probably other ways of doing it, but the file that we've just created here, dark 180, is an image file. Now, if you've got any program that will allow you to display images and histogram them, that's all you need to do what I'm going to show you. I use AIP for Windows. Some people use Maxim, DL, whatever program you use. What you want to be able to do is open that dark 180 file, which is in this folder somewhere. There it is. Okay, it's a dark frame. If you have some way of histogramming it, and with AIP there are various ways you can do it. If I just do min-max, okay, here is the dark frame, and this is a bunch of hot pixels running along here. So what you want to know is, where do the hot pixels start? What works with this particular one is you can experiment with where you cut that off. It's where you plot, where the maximum pixel value that you use in the plot. You just experiment with until you get a plot that looks something like this. And what you can see is that the image, the regular dark frame fades away round about 50. See, pixel value here. If you look at that box, PV, when I'm hovering here, it's around about 50. So what that tells me is that pixel values above 50, which is all these ones to the right, are likely to be hot pixels. So if you set, having worked that out with a program that lets you histogram pixel values, you can go back to ISIS, and you put that threshold in there, 50. And
I've just done this with Astro, and I get a different value, 120. It sounds like twice what you have. And I know that different software treats the numbers differently.
Well, the number you want is the number you judge to be the where that falls off. rather than what a program tells you. This is a somewhere where human judgment has to come in. Where do you think the
I get exactly the same diagram as you. It's just that the cutoff on this program is at 120 rather than 50.
So 120 is out here. Yeah. Well, you could use that value. I would.
My plot relative to yours is scaled by a factor which looks like that too.
Right.
The numbers
okay.
on my program are twice the numbers on your program.
Curious.
Well,
is this?
The warning is that different software reads the same file, but seems to manipulate the numbers for display purposes in different ways.
Right.
And the Pix Insight, for example, you can't get
Yep.
I don't think so.
I was just about to try.
It's a nightmare.
Yeah.
I have to change
David, sorry.
Using AI
yeah, that's what it's saying.
Sorry, I can't hear you.
What's up here? Sorry. Where do you get that histogram window in AI?
If you display an image and you go to measure histogram, that's what you get. And in this particular case, if you choose the button not and 255 for your limits, yeah. So however you want to do this, you've got to make a value judgment where you think above what value of pixel are likely to be hot pixels. My suggestion is, based on that evidence that I got, that 50 was a good number to use. So I put 50 in there. I'm now going to give it a name, hot pixel. And I hit go. Kevin?
One of the gentleman just there is commenting on the different ways that different software is reading the numbers. There is an issue here.
Yeah.
Because some assume floating points, some assume numbers, and they treat floating points differently.
Oh, right.
Between Pix Insight and other programs.
Yes.
Yeah, but the main upshot here is that in my viewer, I get some negative numbers.
Yes, you will do.
Users are well aware of this, but
yes.
There are a lot of cameras with, but there's almost no dark current.
Right.
With offsets, close, that are so close to the noise threshold that you end up with some negative numbers.
No.
And it shows up here. I got hugely concerned about this about 6 weeks ago, and I did some experiments, and it makes no difference.
Yeah.
But maybe it might do in other spectra and other data manipulations, but all I'm saying is, have you ever seen in your dark images any negative numbers? Does it show on your?
Yes, all the time.
So you've got negative pixels.
Yes. The reason that you've got negative pixels is because you have taken all your dark frames, you've taken from all of them, you've subtracted a bias image. So some of the pixels in the dark frame are positive and some are negative. And that's fine. Because of the way because of the way that ISIS then processes your data, it takes your image, it subtracts the offset, it then uses the dark frame, some are positive, some are negative, to correct the image. And it will then subtract the hot pixels in that image.
I don't like negative.
No.
The thing to remember with these negative numbers is it's no longer the image. This is no longer something taken from the sky. This is now a processed image.
Yeah, I know. So many images sit there with some pedestals to get around this because they know it's an issue. It may not matter here, but
yeah. It's if you get negative numbers in a real dark frame, you have a raw dark frame. There's a problem.
No. This is in the process.
This is in processing it. It doesn't matter if this particular file, which we call dark, has got positive or negative. You would expect it to have, I mean, as you see here, this is a plot that goes from minus 19 to plus 22. So it's centered on 0. The mean is about 0, which you'd expect it to be. And some are negative, some are positive.
Well, I did the experiment, I truncated it at 0, and it actually made no difference. So something warning about it.
Yeah, but that's not strictly correct, because if you truncate it, you're actually not then processing the data correctly with that dark frame.
Anyway, yeah. If you're happy with negative numbers...
Happy with negative numbers in that particular context. I haven't hit go yet. I'm now going to hit go. And down in the bottom left corner, it tells me that the number of hot pixels found is 142.
Does this do anything for dead pixels?
Sorry?
Does this do anything
For dead pixels. Cold pixels. I'm just wondering. I don't know what will happen with those. They'll just... They'll be dead everywhere in all your images, won't they? Probably doesn't matter is the answer. I'll just show you what that file we've just created looks like. If I can find it. Hot pixel. Here we are. It's basically a list of pixels, P per pixel, X coordinate, Y coordinate, and they're actually ordered in increasing Y coordinate number. If you ever pull up an image, a raw image, and you look at where these coordinates are, don't be surprised if they're 1 out. Because some image display programs go from 0 to whatever. In ISIS, it goes from 1 to whatever, plus 1. So this worried me when I first started looking at these images in AIP for Windows. The X and Y coordinate from all of these was 1 different from where, from the hot pixel file that ISIS produced. And the penny drops fairly quickly that what ISIS has got is a convention of increasing X and Y by 1 relative to the image. But that's where all the hot pixels are, 142 of them. And ISIS will kindly take all of these out of it. What it actually does is it replaces them by a median average of the surrounding pixels. So we've now created a hot pixel file. What remains to be done is to create a flat field image. Now I have to go and find where my flat field files are. Here we are, flat. So I will copy that flat name into there. Okay, you happy with that? There's the generic flat field file name. I've given it the dark and the offset, which we calculated previously, because I'm going to use those in processing the flat frame. It tells me there are 7 there. If I now just say go, it puts the flat field image in flat 10. It's a 10-second flat, so I've just called it flat 10. That's my name. Now, there is this thing called vertical gain correction. I'm now going to show you what that is about. If I go to something like AIP, again, my same image display program, and I look at this file called flat 10, if I can find it. Where is it? Flat 10. Okay, and I'll zoom out. That's what the flat field image looks like. Okay, you're happy with what a flat looks like. If I use a function which will display the profile, and I take, well, let's do it this way. I take a cross-section of that. That's what it looks like. And this is basically a Planck curve of the bulb in the flat field lamp, modulated with the sensitivity of the camera that's recording the image. That's fine. It's a funny shape. You don't need to worry about that. That's your flat field. If I do it across the flat field image, you'll see it's actually got a profile. What vertical gain correction is recompute the flat fill and replace that by a smooth horizontal line. That would be better if you're going to move the position of the Y position of the spectrum around on the chip. Normally, a tip of good spectroscopy advice is, in your finder, in your guide star image, if you can, always put the star that you're taking the spectrum of at the same X and Y coordinate in that frame every time you do it. With AstroArc, which is what I use for guiding, I can put a cross on a particular place on the guide star image and move my target onto that cross and then say guide, and it will keep it there. That means that I'm always processing at the same Y coordinate of the spectral image. The spectrum is at that level in Y. And that just gives consistency of processing, and it was advice I was given, and I think it's good advice. Just to show you what vertical gain correction does, if I go back to looking at this, you'll see if I go just inside that edge, the Y coordinate range goes from about 360 to 790, let's say. I'll show you how. That's why I have got two numbers that I typed in there. If I take the vertical gain correction box, these two numbers, I can now enter them. I've actually previously typed in a Y min and a Y max that falls within the band of just inside the band of the flat field image. If I now reprocess that flat field image and show you what it looks like, it looks very similar, except that you can see there's a little bit at the edge where I have cut off these little bits at the bottom. If I now do a cross section across this, it sort of becomes obvious what I've just done. I've just leveled up that flat field.
So what would you lose by always running vertical gain correction, just in case your star moves a little
Nothing.
bit?
I think it's better. The recommendation I've heard is it's better to use vertical gain correction because it gives you a more uniform flat field.
Yeah.
Basically, it's just averaging within these Y bands, vertical Y bands. It just averages your flat field, and then uses that to process the spectrum. It makes it less sensitive to whether the thing drifts up and down. And if you always anchor at the same place, it shouldn't matter. But that's what vertical gain correction is about. And that's all the master frames that you need. You've got your offset, you've got your dark, and you've got your flat. Are people happy to move on?
1 second.
Okay, that's fine.
Type on it, then stage. Okay, look at the same file. Okay, the virtual game.
For this, you don't need to put numbers in there. I mean, you could just do it without vertical gain correction, and the rest of what I'm going to show you will work.
Just putting it so we've got an idea of what values to.
Yes, 790 and 350 for this particular flat image that we got. You would, with your own camera and your own spectrograph, you'd have to decide what values you wanted to use for that. Okay. If I now go back to the General tab, what I have to do is in these yellow boxes start typing some of these file names that I've just created. Offset, dark, 180, and flat 10. Okay. Now I've done that, for as long as you use those calibration files, offsets and darks, I tend to use offsets, the same set of offsets and darks for quite a long time. Sorry?
Is it case sensitive?
No, I don't think so. Experiment and you'll find out the answer. I don't know. I don't think so. I just use lowercase. So I tend to keep the same dark for quite a long time, but change it when the temperature changes. So every couple of months I might take a new flats. People say you should take a flat with a series of flats with every set of data. If you do that and you look at them, you find they don't change. They're all usually very similar. So what does change, if you refocus your spectrograph, the flat changes. So every time you refocus your spectrograph, certainly take a new flat. But I find if temperature is stable for several weeks, I don't refocus the spectrograph. And if I take flats, they're always the same. So I don't bother retaking flats every night. But do remember to retake them if you change anything in the system, because then they become invalid. So that's the three calibration files you'll need. We're now going to, well, let me just say that, is everybody happy to move on now? Or as happy as you're ever likely to be? You need to play with this yourself, and you'll get familiar with doing it. It's a lot easier than it seems the first time through. Once you've got the hang of it, you can process a set of master flats in 5 minutes, and then you're up and running. Normally, when you're processing a spectrum, you need to work out the atmospheric response and instrument response functions. These are things which modulate every spectrum you take. And the way to find out what this looks like, this response profile looks like, is to take a spectrum of a star whose real spectrum is known. Because if you take a spectrum of that star with your equipment, you go to a library and you can compare it with a spectrum that was taken and corrected for atmospheric absorption, the difference between these two is the effect of the atmosphere and your instrument in recording that spectrum. And that's the whole process of calculating a response profile, is to take a star whose spectrum is known, and you image it, and you work out the difference between your spectrum and the previously known spectrum of that star, what's often referred to as an exoatmospheric spectrum. It's the spectrum the star would have if you measured it with a Hubble's telescope, for example. The differences between that and the one you measure with your spectrograph is the effect of the atmosphere and the instrument. So, the first thing we're going to do is find out the instrument response function. In this particular set of data we've got, I'm going to use Vega as a star because there's a spectrum of Vega in here. I will use Vega as my reference star and show you how to create a response profile from Vega. So I go into the list of files again, look for Vega. Here we are. There are 4 spectra of Vega in that folder. So let's pick that up. That's okay.
We just keep a hyphen and not the number.
Yes, if you type it directly into the generic name box, you need the hyphen at the end. If you then click that grey one, it will work out there are 7 of those. We need to have a calibration file, which is a lamp file with spectral lines in it. So if we look in the folder, there are actually 2 of those. In mine there's only 1 because I delete. You'll find there are 2. The reason there are 2 is that whoever recorded this didn't switch their camera off before it went onto the second image. So the calibration image -2 is seriously underexposed and you should not use it, just ignore it. You just need 1 calibration image. I always usually just take 1 lamp spectrum. So, and I copy that name into this box.
And given it's just the one, we can leave the dash fit on there. We just have hyphen at the end.
Can we have the light stand a bit? You can see the screen a bit better.
Oh, right, okay.
So do we leave the fit, or does it just end in...
Just dash. Remove the one dot fit if you've got that.
You can see their keyboards though. We'll see how it goes.
Sorry, I didn't quite understand, David.
Yeah.
By setting the file names of the calibration box without the final number at the end, why does that stop it not with both?
That you probably do need the 1 at the end of that. You need the 1 at the end. Thanks, Hugh. You need the 1 at the end of that. Yes, because it's got to know. It's not a generic one where there's a whole sequence of. There's a single file, so it needs to know that's -1. Okay. Now there are two boxes up above. One's root name and the other's object name. I've ignored them for now, but you can use those to automatically populate these. If you put the root name in there and just click auto, it will put that in there. It will also put in there a file, in my case, because I've got _neon dash for my calibration file name, it will put a file in there called whatever, it will add them _neon. You don't want, I've not wanted to do that in this particular case. So I've just literally typed the file names into those 2.
My calibration is greyed out.
It's greyed out. Wow. Andy, can you have a look and see why his... No.
Which calibration is greyed out? Check settings, see if there's
Yes.
Okay.
David,
yes.
I guess for most people here, they should have predefined equation selected because they won't have the file that you have yet.
Right. Let's solve that problem.
Does it matter if people run in with predefined?
I would think it would. I wonder how long it would take for everyone in this room to put that file on their laptop.
Yeah.
Is there any way we can put it? Where we can
I would think. I think it works okay with predefined, so people can probably
okay.
using pre.
Right.
So we'll see how it goes. If it
Yes.
starts to be a problem, and
if it's a problem, Andy takes over at that point.
Yeah. But also, if you want, you could copy it onto a memory stick, which gradually goes around.
Yes.
Then if people want to wait or have problems, they can. But otherwise, I think, like Hugh was saying, is sure.
Okay.
I think with some of this stuff, it's kind of, as well, once you work through it the first time, it's just a matter of getting it working and running, so it'll give you results. But then there are tweaks you can make to make all your results better and better, which you'll learn with time. And it's kind of, it's a continual process, which I think probably never stops.
But what we're going through now is so quick. So many people never get to the point where they can then play.
Yeah.
ISIS is very, very picky, and if you don't have things set up precisely right, you just don't get there. Which should make this afternoon a little bit easier with BAS, which is not as picky on kind of configurations and setups.
Thank you. We just want that to the same folder.
There's a memory stick going round, and on it there is a copy of the folder with all these images on it. You can ignore that because you should all have that. But there's also this Alpi Argon Neon 14 file, which if you've got an Alpi, you probably want to start to use that in the future. But
so if you select predefined above, you get a drop down, and that drop down gives you a list of different kind of inbuilt ones, which includes Alpi 600 calibration module.
Right.
So that's what we should select.
I think so.
yes, we'll see how. Yeah, what sort of fit that gives. I'll be curious. Yes. Thanks, Andy. That's good. Okay, people happy to move on? Okay. Having filled in those boxes on the General tab, we can now click on the Calibration tab. And you'll see it's fed through your image to process. That's the Vega image is there. If I click Display, it goes blank because I need to scroll this down. I'll click off the graticle at the moment. That is the image of the spectrum, and there are sliders along the bottom that you can become familiar with, just play with, and you can see to scroll along the image. And this is a classic A-type star with dark Balmer absorption bands in it. There are two sliders down at the very bottom of this, and they basically increase the contrast, and you can change the appearance of the image. Less useful with the spectrum. You can see how there's a broadening of the spectrum at the very blue end. That's just the optics, the chromatic aberration in the lenses in the Alpi. It's not bad. If you have a focal reducer in your image, your train, you'll find that you probably get quite a large dispersion at the end, or divergence, what they often call a fishtail, and that's chromatic aberration from the focal reducer as well. But
which you can minimise by the spacing.
Oh yeah.
Because I played around with that.
Right.
And yeah, you can get quite severe fishtailing, but if
yeah.
you adjust the spacing,
yeah.
depending on the connector you're using to your focal reducer.
Yeah. Most focal reducer lenses the design is optimized for a particular reduction factor, and you should set your spacing to use that reduction factor. Yeah. If you go away from that, don't expect the thing to perform as well. It will not.
But that is important.
Yes.
Because I used to have very severe fishtailing.
Right.
And then
Yeah.
one of the, I think it was the last course actually.
Yes.
It was Frostfire and said, oh yeah, you just check the different
Right.
spaces.
Yeah. So that's what the spectrum of Vega looks like. If I click on the display for the calibration lamp, we're overheating in here now. You can see, and that's why if you don't change the contrast setting with that slider at the bottom, you don't see a lot of the lines. You have to slide that quite far along, and then you start to pick up the lines in the calibration lamp spectrum, which run all the way from the blue end at the left-hand end to the bright lines at the right-hand end, the red lines. The lines that were in that file I sent you, and I'm not sure which lines we're going to use now. The first one it uses is that one. And the last one it uses is that one there.
So, David, was this taken with the new argon neon or with the?
Yes, this is the argon neon bulb. That's why you've got blue lines. If it was a neon bulb, there would just be nothing down here. You would just have a bunch of red lines. That's why I would strongly recommend using the argon neon, or getting the argon neon bulb if you haven't got it. Sorry?
I'll check to see if mine is out of date.
Yes, it's an upgrade you can get from Xiaoyak. I mean, it's a chargeable upgrade, but it's definitely worth having if you've got a very early Alpi that only has a neon bulb in it.
I'll compare it with this.
Yeah,
So
you'll see.
Maybe a question about the exposure setting for taking calibration images.
Yes.
And that's quite a short exposure time. My experience is 15 seconds. Taking calibration.
Yeah.
Is that because that furthest line in the red there must not be completely saturated?
That would be your upper limit on exposure would be saturation of lines that you want to measure.
Right, so that's an important point, isn't it?
Yeah. Yes.
Because it's very easy. Obviously, I mean, I use a typically 45-second exposure.
Yes.
For the calibration lines that I use.
Yeah. Mine are 60 seconds on the Lisa, but that's just different.
But that's 15. So it's just
Yeah. To check that your lines aren't saturated, you can look at the point spread function of the line. There's a function there called line PSF. You put a box round it, it's barely visible, a red dotted box. Just click point PSF and it shows you what the profile is. And the useful little thing it tells you at the bottom is the full width half maximum of that line in pixels. And that's a way you can work out yourself what your resolution is. Because it tells you, if you know that the full width half maximum is 4.5 pixels, and you know your dispersion in angstroms per pixel, the product of those tells you in angstroms what the full width half maximum of that line is. And if
the line is saturated, you get a
flat top, that's right. Yep. And you. Yeah, I guess it's doing that automatically. If we look at another line.
The other thing you want to do, of course, is not get too close to saturation. Some CCD cameras will suddenly cut off, but they'll have sort of inbuilt technology to gradually reduce it.
Yep.
Yes. Value. So I think probably 2/3, something like that.
Mm-hmm. Yeah.
Just to be absolutely clear that ISIS correctly to run its sort of automatic calibration process, all of the lines that it's looking for must not be saturated.
Correct.
None of the lines.
Yes. Yeah. Do you all hear Hugh's comment there? That you should make sure when you expose your calibration frame that none of the lines you intend to use for calibration are saturated. In other words, end up with a flat top, or even get close to saturation. You can always go and look at the pixel count in those lines. I mean, if I go back to ISIS and I hover over the center of that line, you'll see that over on the right-hand side, there's an I, which is the intensity in that line, is 7737. You could actually have exposed a lot more on that.
What is it? That's a short exposure.
That's a short exposure, which is, I would say, almost undersaturating or underexposing this calibration frame.
I've noticed that the blue end of these calibrations, that all the peaks are smeared out to the blue end.
Down here, you've got to be selective in the lines you use. For example, if I look at this line, the bright one, sorry, I clicked too much. That line is reasonably sharp.
Yeah, it is, but it does have a tail off on the blue side.
It does have a tail off. Yeah.
Where does that
But
come from? Is that a...
just blending of lines. There are an awful lot more lines in here that you can actually see.
Right.
If you look at an argon, if you get a list of argon lines, element lines, there are hundreds of them. These are the really bright ones that we're picking out and using. And what ISIS is doing is fitting to this peak. So it doesn't really matter if that's got a tail in it there. The important thing is there's a well-defined peak that it can use to center.
I found it really, really difficult to identify the lines.
Right. Is this a focus issue?
I didn't think so. I paid a lot of attention to the focus.
Yeah.
I thought I got it right.
Yeah. It's like.
And you see it on the same sort of effects here, right?
Yeah. This spectroscopy is a compromise. Everywhere you go, you're having to compromise in a way, or making value judgments. If you're trying to focus your spectrograph, it's generally recommend you try and focus on one of those lines here, in the sort of middle part of the spectrum. And what you then find is that the blue lines are a bit poorer focused and the red lines are slightly poorer focused. That's the design compromise in the design of the spectrograph. It's made at a budget price, basically. And the optics and such are such that that's as good as you're going to get at that price. If you know, a professional spectrograph where you spent hundreds of thousands of pounds making it would be sharp all the way across the spectrum. But we don't have that kind of spectrograph, so it's a design compromise. But what you can do in using it is to try and focus in the center of the spectrum as sharply as possible.
Yes.
If you're curious and want to understand a little bit more deeply how the focus is optimized, something you can do is you just take an image like that, and using this line point spared function, you go and you measure the full width half maximum of each of your calibration lines. Okay? Assuming you know the dispersion parameter, we'll come to that in a minute, but the dispersion parameter in angstroms per pixel, multiply the two numbers together, and that gives you the full width half maximum in angstroms of that line.
Then you get an R value. Is that right?
And then you can divide the wavelength of that line by that full width half maximum, and it gives you an R value of that line.
And then you can plot the R value by wavelength.
Plot that for all your lines.
Yeah.
And then you'll see what it really looks like.
Okay, whether you've got
What I find when I do it, as I got a curve like that, the resolution in the middle is better than the nominal resolution of the spectrograph, but the resolution at the ends is lower. And that's because of the quality of the optics is such that it's not giving you perfectly sharp lines at either end of the spectrum. But you should find that you get a value that's close to the nominal value of the spectrum. With an LP, it's 500-ish.
I think I got 550 in the middle.
That's good. If you can get that, then you've got a well-focused spectrograph, I would, at that point. But don't be surprised if it tails off and the lines get a little bit soft at the ends. They will do, because it's just the compromise in design of the spectrograph.
I suppose for me, it made it really difficult to actually identify the lines in the blue end of the spectrum.
Yeah.
So that I turned to using Vega or Stein
Right,
as
right.
calibration.
That shouldn't be the case. If you're exposing long enough, you want to take a long enough calibration frame that if you figure out which of the bright lines, I mean that line intensity is 6,000, no, it's 11,000, okay, 12,000. So you could probably expose for 3 times longer here without getting close to saturation. And then you would get 3 times stronger lines on all the lines in the spectrum. That might bring up your fainter ones better.
Okay. Have you applied the flats to the calibration to the neon file? Because that will brighten up the blue.
Yeah, that will happen when it does the processing, boom, all the way through. I don't think that this is a raw image that you're looking at now.
Yeah. Maybe my problem was that I was using raw or close to raw images rather than having them brightened by applying the flat.
No. Sorry.
And by the way, I was processing that from
right. Yeah. I think these are raw images, because if you look up there, the intensity value is about the background is. But I wouldn't swear to that. Okay, so
David, I missed the tilt and smile bit.
We haven't done that yet. There are two corrections that you want to do to this spectrum now. They're called tilt and smile. If I look at the display of the star spectrum, this is quite well adjusted equipment so that the line is pretty close to being along the x-axis, but it won't be perfect. You can correct that by setting a tilt parameter, and you do that by you just draw a box around the spectrum, like so, and that helps to show whether the thing is aligned or not aligned. But you then click the tilt. If you look in the, well, let me cancel these 2 boxes there, these 3 boxes, and then you'll see it putting a value in. If I click tilt, it's put a tilt angle of minus 0.17. That's the correction it will automatically apply to all the spectrum to just bring them up so they're perfectly along the x-axis. And the other correction you do with the calibration lamp, you draw a box around one of these lines, making sure you completely enclose the line, and then you hit smile, and it fills up the 2 smile Y and radius. That's the radius of curvature of the line, which again is a feature of the optical performance of the equipment. Some spectrographs have strong smiles, some have less smile. The LISA, in fact, has no smile at all. The lines are dead straight, but it's just different design.
I remember reading once, Christian Wheel's recommendation is that spectra should never be more than half a degree off horizontal.
Yeah, I think that's pretty good. It's worth spending a long time orienting your camera as accurately as you can to get the tilt 0. You'll never get it perfect and the tilt corrects, but definitely don't go in with a big angle. It really screws up the processing. Because when you integrate across the spectrum in Y, you're taking different wavelengths in, basically.
Smile is blanked out in version 597.
Have you set the instrument to be an Alpi with calibration mode? Go back to settings. It should be Alpi with the calibration module. Yeah. Okay. Are people happy with this tab?
Is there any way of squeezing this way so you get the entire
No. You have to scroll along the bottom. It doesn't have a... No, at this point it doesn't have a way of doing that.
Unless you get slightly different tilt values in different parts of the
Yes, probably, but I think that's in the noise. I wouldn't worry about that. The next thing you have to do is you have to tell the software which part of that image is going to constitute the spectrum of the star and which part is sky background that you want to subtract. There's a little box over on the right hand side called graticule. I clicked that off before just to keep the image clear. If I click that back on, you'll now see it pops up a number of lines. There's a box here called binning zone adjustment. If you click on that, you get a little window opens up, and
the green lines just appear.
they don't appear. That's probably because if you bring up the binning zone adjustment box, there's a little box, tick things within that, says display sky zone. Very out of focus, unfortunately, on this projector. You have to tick that. So there's two things you want to tick: the binning length tick box and the display sky zone tick box. Make sure both of those are ticked. Untick, well, you could untick predefined values. I mean, at this point. The binning height is the blue. The difference is the width of the two blue lines, which constitutes the part of that image which is going to be, if you like, compressed vertically into a single intensity line, which will define the strength of the spectrum. You want to make sure you include all of the spectrum in that, but no more than that. You want to exclude as much sky background as possible. The way I used it, this is just a little technique I've developed for finding out what that should be, and I think for me it works. If you put the cursor somewhere on the fat part of the spectrum, say down on the left-hand end there, where it's really fat, and just click once, click the mouse click once, and use your up arrow on the keyboard to just move that up and down. You see, it goes up and down. The little cross will now go up and down. If you look at the right-hand end of the display, where it says I, under the X and Y, there's an I value. As you click that up, you can see I going down. That's the intensity of the image at the point the cross is. If you go way up into the sky area, high above the image, you're getting a low value of 280-ish. And gradually it bubbles around 200, 300. And at some point you'll find it suddenly starts going up. Now, it's rising up rapidly. And where that transition tends to happen, you're moving from the uniform background to picking up the tail edge of the spectrum in an area where you really don't see it. I mean, I can make that even more extreme by blowing it up. Really. You could start to see it's quite fat, that image. But if you scroll up here, you can start to pick up where its edge is. And that's about the point at which you want to set your blue line. You might find an easier way of doing that yourself. This is just the way I tend to do it, because every spectrum you get is different. You need to have some way of doing it, of assessing where the sky background starts to ramp up, because you want to integrate all of that spectral profile. If you imagine the profile in Y, it's a bell curve of some sort. You want to pick up as much of that as you can.
Just a question then.
Yeah.
Wouldn't it be better to set the blue binning zone when you've adjusted the tilt first?
Yeah.
Oh. You're setting it there with the spectrum still slightly tilted, so you're kind of forcing a wider zone.
Yeah, but that's one reason to try and work on getting your spectrum as horizontal as possible before you start. Yes. The program doesn't do the correction before, so you haven't got the option. It will do it all when you process the spectrum. But Okay.
It's just in back, you correct the tilt before you set your binning zone.
Right. Okay.
And therefore, you're setting your binning zone on a perfectly horizontal spectrum, which makes sense.
Yep. Well, you might find a better way of doing it in ISIS, but I find that's just a convenient way of measuring where it is. And then you set the binning height to be, that value 35 is the defined, it's a plus or minus value in Y, which is where currently the blue line is now. If I change that to 45, you'll see that blue line automatically instantly moves up. But by scanning across it, I had determined that the best value I thought for that binning zone was 35. That gets all of the spectrum and as little sky as possible. The other parameters you've got to set are for the sky background, two tram lines above and below the spectrum within which it measures a sky background. I tend to use fairly big numbers in there, 50 from plus 50 to plus 100 and minus 50 to minus 100 to get a good mean value of the sky background. If you click the predefined values box, you get a lot of options that the program will give you as well. So,
just a general question. How big should you make the sky background zone?
No idea. Make a judgment. Yeah, that's what I use. And
yeah. So what are the pros and cons of making?
well, if you make it too small, you're taking a mean of too small a set, so the noise is going to be low. The bigger you make it, in theory, the lower the noise value in that background. That would be my answer. The one thing you have to be careful of is there isn't a faint star, which was sitting further along the slit from the target, and will appear as a spectrum possibly in one of those lines. And the way to check for that is to play with this contrast, really wind the contrast up as high as you can, and make sure that there isn't. In this particular case, actually, there's a good example. In this case, if I wind that really up, there's a star along there, isn't there? So in this case, processing this spectrum, I would increase that probably to 60, or maybe even 65. And that's moved the upper green band away from that star image.
And just another quick thought on that is, when you're, I'm not sure you may have said this already, but when you're setting your binning zones, what you suppose want to do is go beyond where your spectrograph is actually putting the spectrum of the sky. So
Yeah.
if you go too high or too
Yes.
low.
Yes. Now, that's another point, that this sliding up and down let me just restore that to a more reasonable level. This vertical slider on the edge shows you the extent, the whole image that you've recorded, okay? This is a little bit of a diversion, but I think it's useful. If I go back to my image of the sky flat, this is the whole image that your camera is recording. The bit that's lit up is the bit that comes through the spectrum. The spectral slit. All the black stuff above and beyond it, there's no data in there. If you can set your camera control software to just read out a part of the spectrum between Y limits, above and below that, you will save yourself at least 50% of your disk space from then on. Because every image you record has got all of this black stuff up here and all of this black stuff down there. There's no data in it. All you need is the part of the image that contains the light that's come through the slit. And I know with AstroArt, there's a way of telling it, when I'm reading out the camera, just read out this part of the image. And you'll probably find that with all camera control software, there'll be a control there. If you take the time to find out how to use that and fiddle about with it, you can just get your camera to read out the spectrum, or the bit of the chip that covers the spectrum, the light coming through the slit, and you'll save more than 50% of your disk file space for all future spectra you take. And spectral images can be quite large, and you can accumulate a lot of them. That's a bit of an aside, but it's useful to think about. So if we go back to ISIS, what you would find if you did that is that you'll probably find you'll see the limits of where the spectrum is recorded as you scroll up and down, and then you want to make sure your tram lines for a sky background are within that range of where the limit of the slit is, as Andy mentioned.
It's easier to do it if you look at the calibration image instead, because you can actually see
Yep.
where the lines are.
Yeah, you can see where it is. So, and one other thing I'll mention is there is this thing called vertical coordinate. Well, two things I'll mention. The first one, vertical coordinate, and an auto box which is ticked. If you have a bright spectrum, if you have auto ticked, it will always work out where the center of that spectrum is. That's the Y value of the center of the spectrum. If you have a very, very faint spectrum, and in my case I'm talking about 14th magnitude stars, probably a bit fainter with an ALPI, it doesn't always pick up exactly where that is. And what you would do then is you would untick auto, you would type the Y coordinate where you know that spectrum is, and you go back to the general box and you tick the fixed Y coordinate for sequence box. And what that means is every image it processes, it always assumes the spectrum is at that value, even if it can't see it. It's so faint that its detection software isn't going to pick it up. It means that you will then integrate all of your faint images correctly, and you'll eventually pull the spectrum out. It's just something only to use if you've got a very faint spectrum, but it's just something to know. And the other crucial bit of information here is to help it work out how the wavelength calibration works. Up to now, we've got an image in pixels. We've got to tell it how to convert pixels to wavelength. We've helped it by giving it a dispersion file, which tells you where the wavelengths are of all of those lines, but it doesn't know where it is in the x direction. So what you do is you display your calibration image, you pick one of the lines. Let me just blank that box out, the orange box out. You pick a line in your calibration. We know the wavelength of that particular line is 5852.49. So I have typed that into the x coordinate box there. I've typed the wavelength of that line. I've told it what the wavelength of the line I'm going to use is. I then click on that line, just where it crosses the red line, and it puts 903 in there. And that is the wavelength, that is the x coordinate of that line. You can see if you just nudge your cursor, it moves 901, 902, 903. But the important thing is to get it pretty close to the center of that line. That is then telling it that, if you remember in that, now I'm not going to, in that wavelength file, there is a dispersion parameter that tells it what the angstroms per pixel is. If it knows that value, and it knows the wavelengths of all the lines, it can work out where the x coordinate of each line should be on that chip, on that image. And I've told it where one of them is. It then goes away and looks for all the others in the right place, and if it's all working right and you've got the numbers right, it will pick up all of those calibration lines for you automatically and just calibrate it. Have you understood what I've just said? It's pretty crucial.
Sorry, does it scan? Yes.
Sorry.
It scans that line. You get on exact because otherwise you can miss it.
Yeah.
And that's where.
Can I also say that because this is a predefined mode, because this is the predefined mode, it's stuck the correct wavelength for that particular neon line
Yeah. It should. Yeah. It does. It shouldn't matter which mode you've got. Which mode you've set for calibration. Just where it crosses the red line, because it obviously it's got a bit of a smile. It's skew, but just click it about where I've got the cursor now. See where I've got the cursor up there. Just do a double click there, and it will fill in 901 at that point. And I think, if I've got it correct, I've told it everything it needs to know now. So, I've got my star image, I've got my calibration frame, I've given it all the parameters it needs. I can now go away and calibrate that image in wavelength. I do that by clicking the Go tab, and this is where you cross your fingers. Ha! Name of object. Ah! That's because I left these lines blank. Okay. I should type Vega in there. That goes in the FITS header. It needs to know what the name of the file is. What the name of the object is to put in the FITS header to identify it. It might now work. Yeah, bingo. Okay. And just to see what we've actually done, we've now produced something that looks horrible. But don't worry, I'll explain why it looks horrible. The important thing is, if you now can scroll down that list of output, there's lots of useful information in there. It's really a stream of consciousness as it's doing the processing. It's writing a lot of stuff up there. But useful things to look for. Mean profile of the mean median for the profile. It gives you the intensity value that it's found for each of your spectra. What you want to just double check is that these values are all within about a factor of 2 of each other. Are you seeing what I'm seeing?
I just got an error message saying that I haven't got a cosmetic file.
Right. You better give it a cosmetic file then. And then it might be happy.
It's under masters is the cosmetic.
Masters.
So I've got something.
What you've got to make sure is the name of your cosmetic file in the masters must match the name of the one in the...
You have to go back to the general tab, and where it says cosmetic file, type in hot pixel.
Cosmetic, I think you've got a different name.
Make sure
down here.
Yeah.
What you can do is, if you don't want to copy and paste, you can click the little box next to it, and it will allow you to select the cosmetic file.
Yeah. Yes. So remember and fill in that box there on the general tab, which is the hot pixel file. Okay? I'll redo that. Has everybody got a result when they hit go? Hello.
Well, the spectrum ones, you had some blue lines on there. I cannot make those appear on mine, though.
Have you clicked graticool? Have you got now click on the binning zone adjustment window. Have you got the right hand, the thing, binning zone ticked as well? The right, very right. Okay.
So, I guess things you reckon the hot pixel
What you need to do is know a bit about your spectrum. So you know, this set to the same yeah. And so you then also know lines, 5/8.
So then back to the master.
So that sometimes you can get images which are available.
Okay, so do I
Assuming that's the line, which you may as well use to see if it goes wrong.
And so the fact it's run is a good indicator.
Have you got this far?
The first thing we got there
Is it? Oh, wonderful. Progress. Yeah.
Something more positive this.
Eureka!
I mean, mine's coming out with an RMS of 16, and I wonder if we've got the right pixel size.
Right, see, I'm getting a 0.1.
Yeah, but that's not in Armstrongs.
That's in pixels.
Yeah, have you got it in Armstrongs?
No.
It would be on this in this list somewhere.
Basically, it has to be the line.
It's got a resolution at the bottom.
Can I see?
Yeah, sure.
Yeah.
I'm not sure what you're saying.
Or maybe just uncheck the actual.
Yes.
What you have to do is you have to make sure that the line you select corresponds to the wavelength in the little box. So you can't click on just any line.
Yes.
So you have to know a little bit about the spectrum you're looking at.
That's very bad
to know which,
calibration. I
which
think
is
you've got
the
the wrong
way,
pixel
which is the
size.
line for that wavelength.
Because it depends on the camera that Francois was using when he made those.
Yep, I know. That's.
Yeah, we put in 6.45, which was the one that was on the screen.
Yes.
And if you have a look at the profile, for example.
So I don't know.
Let me show you something else. This is if we go back to that and we use file mode. This thing is the difference between how it's doing it and why file mode I think works. If you now process it with that set of
yeah, and you've got much better.
I get a better result.
Yeah.
With that set of files, that list of wavelengths, because I don't know what wavelengths it's using when you just go to this predefined mode.
But we know the pixel size for the camera that Francois used.
It's 6.45.
Okay, yeah.
There's usually only two cameras that most people use. There's that one and the one that's 4.54.
Did he bin it? Running to this?
Don't know.
Because that's important too. Sorry, because I always use this other method. I always use the calibration because I've got a file of this, and I find it works if I get the pixel size right.
Okay. Yes, that's what I mentioned earlier. You can play with that number to tweak it so it does fit.
I'll go and have a look at his tutorial because I might have where he uses this because he might have said what pixel size we should be using.
Yeah. Sometimes changing this value here makes a difference as well. 901 to 902. Let me go back.
See if it gets.
Wow, something gone way wrong there.
RMS has come down a bit.
Yeah,
but
that's a very. You want to look at these numbers as well. That's the error on each line.
Yeah, they should be
huge. They should all be less than 0.1.
You've got a different. Oh no, that's just
not. That's
text.
just text. It doesn't matter.
I think the pixel size is wrong.
Well,
I'm only saying this because I've used this method so many times. If I get the pixel size right using that, it does work.
But using that, it works. So I think the pixel size is correct.
Okay.
I think the way is in this predefined mode. It's doing the calibration differently, and I'm not sure what lines it's using.
So we need the file mode file.
Did yours actually work successfully? Because if you look at the profile you had...
Oh, I know, I've not got there yet. There's a problem.
Because other people have, and I'm not sure whether therefore that is a... do you know there's a problem?
Yeah. If you go to that, this is not. I think this is a bad run, but if I just, okay, that's the profile you get.
Yeah.
But it's initially you don't get that. I'm just trying to figure out. I've not changed anything that matters.
You changed the
yeah
901 to 902, didn't you?
Yeah, that shouldn't make a difference. Or not big difference. Right, if I process again, this resolution is
6,000.
There's something
If you go to calibration, what I did find was a 901 seemed to give a more realistic resolution, but the profile looked completely wrong.
Yes, well, I'll explain why in a minute.
So I think I don't know if the pixel size is right. That's the other thing.
Yeah, okay. The profile is completely wrong. The reason is there's an artifact away down 2,000 angstroms. What you need to do is you need to crop the image in a sense that you need to set crop so that it chooses a sensible range and apply that. I was going to explain that when we got to
that's
this
good.
point.
So that I think therefore means they're okay over here.
Yeah, that's fine. You're okay. Yeah, I'll explain why you're getting something that looks...
Basically, one thing we found is people who have 902 seem, for their pixel, seem to have got a problem.
Yeah.
Not processing the calibration correctly, but the 901
works better. Yeah. Yeah. So. Yeah.
So if you look at your profile,
no, 901. Can I just check that you're all using the wavelength 5852.49 on the calibration tab? The x coordinate of line at wavelength, and then that box, you should put 5.
Mine's greyed out. I've got 6506.
It's grayed out. Okay, okay. That's fine. It's telling you that number. It's not letting you type it in. That's because where we have because we're using predefined mode, it's going to use that. That means that you have to now use that bright line there. That one is the one. That's the line at 5852 angstroms. So that's why we're clicking on that one.
So if I'm going on 65, I've got 6506.
Have you?
Where's that come from?
I've no idea.
Resolving power 617 better.
So it's whatever that's
Okay. How far round has the memory stick with that file got?
It's here.
It's here. Okay. The sooner everybody can get that file, the better.
Yeah, because it works.
Because it works.
Yeah.
Which may be why mine's working, because I was supposed to get the file.
No, it's going on the other areas.
Mm-hmm.
Can I see your calibration screen for a minute?
The latest.
That box is bright because I've got file mode ticked. That box there is one that I can enter a number into.
I can't.
No, you can't. The difference is because we've got different buttons, radio buttons typed here. If I go back to predefined mode, when I look at calibration, that's grayed out because it thinks it's going to it knows what one it wants me to use, and it's put the wavelength in there, so that it knows it wants me to click on that one there.
That's the line I was.
Yeah.
David, where does that file go in the file structure?
In the same folder.
Just anywhere.
Yeah, in the same folder as all the other stuff we're using.
You know what wavelength resolution power is calculated? In the dialogue box, you can go. When you're in the dialogue box, you go. The very bottom.
Yeah.
You know what wavelength that's calculated at? Is it the 585?
No, it's, well, that will be the value.
It looks low, so it's at the low wave.
So I've specified that file.
Yeah.
So the
Yeah. That value that you see at the bottom, the R value, it appears there. That's the number it uses to fill in that box. And it's the number it writes in the FITS header. No.
But again, it's not just going to ignore that.
What it is, what I found out from Christian Buell with great difficulty is, when they only had a neon light source, he took 6 bright lines in the neon spectrum. And what ISIS does is it measures FWHM for those 6 lines and works out an average resolution based on those for that spectrum. And that's hardwired into ISIS. And that's how it calculates that number. If you want to get a big number, you focus your spectrograph so that the red lines are really sharp. And then you get a big number there. If you focus it a bit to the blue, that number will go down. Doesn't matter, don't panic. But that's the peculiar history of that calculation.
So I think what Andy was saying was the profile for most of us is probably okay, just because there's an artifact on the right at the far left-hand end.
Yeah.
Can we crop that out so we can see?
Yeah, I'm going to explain that in a minute. Once everybody's got the goal listing to work. Has everybody got the goal listing to give a list of stuff in that window? Okay. I was just going to scroll down and explain some useful things in there which you might want to pay attention to. Part way down there is a list that says mean or median for profile number 1, 2, 3, 4, 5, and it gives you a count. That's basically an ADU count. What's that telling you is the strength of the signal in each of the spectra that it's used and amalgamated into the final spectrum. The reason I'm mentioning that is if you're observing under dodgy conditions and you get clouds that drift through and some of your 5-minute integrations suffer, you'll see some of these numbers dip down, and if they dip too far, actually get rid of that spectrum, because what it does is it increases the noise in your final spectrum. So pay attention to, if you're observing under variable conditions, just check these intensity levels for the spectra to make sure that all of your spectra, this is if you weren't sitting there staring at the spectrograph for an hour while it was doing these spectra. Check those. And then scrolling down a bit further, you'll see a wavelength fitting error. Now I've cheated here. I've used my Argon Neon file that's coming round to calibrate. The reason I use that is it gives you really nice errors down there, really small. What you're looking for is these numbers to be less than 1, ideally. There's a couple of high ones up there. But this is the wavelength here. So this is the blue end at the bottom and the red end at the top. And what this is telling you is that the fit that it has done automatically, given the calibration file, is it's matched all of these lines really well, maybe not so well at the top. And that's what you're looking for, is numbers like that. If you get numbers in here like 5, 10, it's a lousy fit, and you've got to go back and fix something. And then, sorry, your numbers are different.
Well, no, it's more the layout is different.
Is it? Okay.
Different version. Yeah, you're using a different version. I'm using the July version, the very latest version. Yeah. Mine says wavelength deviation instead of fitting error. But I guess it's the same.
This is probably a change that Christian Buell has put into the 0.7 release for his UVEC spectrograph. This is one of the irritating things about it. Yeah, the numbers should be the same. You may get a change in the presentation of the information. Sorry?
The overall root mean square error.
Yeah.
What would you say is a kind of maximum?
Well, you're looking for values which are that's actually reasonably high. 0.8 is quite high. You'd be looking at about 0.25. When I was processing this data the other day, I was getting 0.25. So with all the changes that I've been doing as I've been running through it, I've obviously changed a parameter which probably worsens that slightly.
Yeah, 0.12.
0.12 is good. That's what you're getting with the predefined mode.
Yeah, predefined.
Right. Okay. Let me. And 901 for the wave.
That's for the database, and then that's the start date. So you won't really want that.
Ooh, I'm getting 16. Ah. That's a big. That's.
There are a whole series of RMS numbers. No idea where they
Yes.
Primary wavelength deviation. Inverse dispersion.
If I use predefined, the list file for the wavelengths, and I put 902 in for the center of that line, that's the result. I get 0.25, which is, I would say, is acceptable. Yes, but it shows you how sensitive it is to what these numbers are, how well you hit the center of that spectral line.
So which RMS value is that? One is very small, one is very large.
Sorry, where? See, all of those are now less than 0.1, or around 0.1. And it's the root mean square of all of those.
where ISIS just isn't behaving. Right. So, for example, setting it to English, closing everything, still stays at French, and getting onto the final go stage, I don't getting error messages.
Right. Come down and have a look.
It's in French, and it's big long, it's a kind of long list. It's got a big page. So if we go back to the one on the right here, so if you, so it all looks as though it should. I've basically replicated what Derek had on his, and clicked, to go. So if you click on go now, just end up with this.
Wow.
Now, what's happened here is this file name.
Yeah. So if I go back a step and see if you've got things set up, so I go. So as long as configuration, if you go to general, which is tab 2, and I think you've got a missing file, so in your big bright yellow box, you're missing a file name there. So, yeah.
I mean, you go back to general tab and see what's in there.
Was that the message in French?
Yeah. Or, well, it's a whole page of, I can understand some of it about kind of installs. It looks like it might be drivers, but it's, I suspect it's something quite deep going on, and I think it might be that there's something up with the install, because the install isn't changing from French to English. So it's keeping it even though it should be responding, and so I wonder, we might give it a go in a minute if there's a... I think the other thing is we could maybe have a look over lunch if it's...
Yeah, all the numbers look okay. Go back to configuration settings tab at the moment. We have to get you into English at some point as well.
Yeah, and I don't know why it isn't changing.
No.
And it's just making me suspicious there may have been something corrupted in the install somehow, or not. Kind of.
Yeah, all of that looks sensible. Yeah.
Well,
yeah, that's better to do that.
Yeah, I did, and I actually did click that, and then it lost it. So yeah, click we again.
It didn't work. So.
Yeah, it just kind of when we went back and checked it again, it had unticked. So it's worth trying. So give go another go. System IO field could not load file or assembly. I mean, it looks to me like it's probably a deep problem in the setup, either a Windows 10 library,
finding the files.
Yeah, or something in the installation. So, do you think, as we've got half an hour left, do you want to carry on, and then perhaps we see?
Yeah, I want to get to the end of the process, and then come back and deal with individual problems.
Yeah. Okay.
Right. Okay, if we're assuming you've pressed the Go tab and you've got a list of results like this, if you hit the display profile, you get something fairly horrible that looks like that. The reason is that the file of Vega that you've been processing has got information right down to very low wavelength. If you look at where I've put the cursor and you look at the wavelength, that's 2,800 angstroms. There's no real data down there. There's noise in that file which is corrupting the display. You can see there's a huge negative spike on the left-hand side. That's a feature of what was in that Vega file. It wouldn't be like that if you took data with your system. The cleanest way to deal with this is you use a crop. Down here, there's a button called crop. Okay? There's a button called crop. It's now showing closed, but lower right of the display, if you hit crop, you'll bring up a little window with two wavelength ranges in it. I suggest you set something like 3,700 and 7,400 as your minimum and maximum, because you're not going to have useful data beyond those limits.
We found we could make a display by unticking automatic threshold and setting the high level to 25.
Yeah, okay.
So I've cropped and my H alpha is still as well. So I can see the spectrum now.
Ah, right.
It's still at 4,800 angstrom.
Wow. If you apply that, it throws away the stuff that's screwing up. All it's doing is screwing up the display. That.
If you're having problems like that, I'd suggest
it's not H alpha anyway, that's beta. H alpha is at level 6585.
Yeah, there's.
Where's the? I go and have a look at the calibrations again, and I'll have to check that it's still too small.
Yeah.
It's possible those might just throw it out.
You've got that file now, the Argon file. Try using that to see. Has everybody managed to get this spectral profile now? This is the raw spectral profile of Vega, including the effect of atmospheric absorption. And if you put the cursor on any of these deep Balmer absorption lines, you should get the appropriate correct wavelength for those lines. Because this is wavelength calibrated. Okay.
So there's, I think there's a few people who've got some calibration issues.
Yes.
What I suggest is go with it as it is.
Yep.
It's probably a bit of, particularly with ISIS, it's very kind of fiddly, tiny changes have an effect. And it could be things like your smile or your tilt are just slightly odd, maybe the kind of line or the place where you measure, particularly the smile.
Right. Okay. So what you've got now is a raw a spectrum of the star modulated by the instrument and atmospheric response, and we want to find out how to calculate those and correct for them. Well,
I want to reset that, and if I try and go into the crop again, even if I just do apply,
it will complain.
It complains.
Yes, because you're trying to crop already. You'd have to, if you made them slightly shorter, it would then work again.
So how do I get back to the original?
Run go again. Yeah. So what I'm now going to do is show you how to wavelength calibrate. Not wavelength calibrate, correct for atmospheric distortion. If you go to, no you don't go to that one at all. You go to response, and select reference spectrum. Now what we'll do, because we know Vega is an A0V star, we'll go to the Pickles library and we'll pick A0V and select that. It goes and finds in the database, the ISIS database, the spectrum of that star. And if you click response and move this out of the road, what it's now done is divide the raw green spectrum by the spectrum from the database, which has come out as a rather mushy purpley sort of colour on this projector. And if you say OK, because this is the response curve you want, click OK. All is forgiven. What happened there? Right, there's the response curve. Now, it's a bit noisy. You want to smooth that. You can do that using the continuum function. When you click on continuum function, you always get this error, and you can ignore it. Just say OK. Nobody knows why it's there. Probably Christian does, and he's forgotten. You want to smooth over. You can do that just by clicking, like what I'm doing. These two are the atmospheric absorption bands. Normally, you will just click over those. You can smooth this bit of the spectrum as well. Smooth that bit. Oops. It's getting a bit subjective. The other way to do it is by using this slider. If you set to times 100, you can adjust that scale by moving the radial buttons up and down so you get a sensible value that works. Times 100 and move the slider, the blue slider, up and down to about that position. And what you're looking for is a good fit through all of that, basically ignoring the wiggles, which are these little bits of absorption. Lines that are, it's a mismatch between the resolution of your spectrum and the resolution of the spectrum in the database. But basically getting a nice smooth value for that. When you've got it, you just click OK. And that's your response curve. You now want to save it. I'll just go through this once quickly so you can, and then maybe go back if people want to see in more detail. Response, we'll call it. Okay, and I'll just do a little copy of that. I'll save that and paste that into the general tab where it says response. So I've now worked out my atmospheric response profile, told it how to do it. I now say go again. In other words, reprocess the spectrum, correcting for atmospheric response. And now we have got a proper spectrum, correct spectrum of Vega. Now, to see how good that is, I can compare it with Vega, the spectrum of Vega that's in there. If this is the one that works. Yeah. And that gives you some reassurance that you've now correctly allowed for atmospheric and instrumental response. You've got a spectrum of Vega, your blue one, which is pretty close to the red one, which is the library spectrum of Vega. It always tends to be a little bit off in the blue, probably because of the chromatic aberration effects in the spectrograph.
And so the relative intensity is normalized at that wavelength?
It's all normalized at that wavelength. You see, if I set the wavelength to 6700, you can see that the intensity is 1.0. So it's automatically normalizing them at that. And another thing you can do is that full button at the top is really just a scaling which opens up the spectrum, and you can then look at the whole thing in more detail. And what you will find is that the wavelength calibration works well up to about 4,100, and then it starts to drift off. And the reason it drifts off is you're now extrapolating beyond the wavelengths that you've calibrated this fourth order polynomial with. This is a fourth order polynomial, and the bluest line you calibrated it with was about 4,100. You're using an extrapolation of that polynomial to calibrate the stuff even more to the blue, and it gradually gets less and less accurate. If we had some nice strong blue lines down at 3,900, we could fix that, but there aren't in that lamp that I'm using, and the Alpe's using. It doesn't have lines. You think you might have found some that work? Right. Okay. I'll experiment with putting that in and see if it helps. But so we've now gone through the full cycle of calculating a response curve, using it to prove that we did it correctly. That's all we've done. We've just shown that applying that to Vega, we get back to the correct library spectrum of Vega. What we've not yet done is measure another star whose library spectrum we don't know, an unknown target star. I will quickly run through that process now for a different star. We'll do it for Altair, which is one of the ones that's listed on the in this folder that we've got.
David, before you do that, can you just show us again where you pulled out the reference spectrum from? Because I was pulling your file in.
I pulled it out of ISIS.
So in the menu option, so in ISIS.
Ah, right, okay, let me go back to
reference spectrum in to do the calculation as a response to.
compare. That's where my ISIS.
Yeah, so to apply the reference spectrum to the active spectrum to calculate the response.
Where is the reference spectrum?
I missed the sequence of steps you did to do that.
I put it in there.
Yeah. But I mean, just the practicality. So you've got your profile, uncorrected profile.
Yes.
What do you do next? Drop the reference spectrum in and then calculate the response curve.
Yeah.
Would it be worth shall we look at that again afterwards? Because what we can probably do is very quickly do a reprocess.
I can do that through the cycle again.
Yeah, and then
I just want to go one step further, which is to say, in real life, what you'd be doing was you'd have done this on a star whose spectrum you know, because it's in the library. You now want to correct the spectrum that you're just measuring for the first time. A nova's gone off, nobody knows what the spectrum looks like. You've got to be able to correct that for atmospheric response. We'll pretend that this is Altair, which has just gone nova, and nobody knows what the spectrum looks like. So, it's not what I want. Where's the Altair spectrum? Down here. What on earth has happened here?
Yeah, I think it's.
Oh. Ignore all that.
Do you want a quick sneak of how to do that more quickly and get it in? Because if you go to image and select it and then go next, it automatically populates for you in ISIS.
Yes, sorry, what do you mean?
So if you go to image, tab 1.
Yes.
And then go
next.
Not next,
no.
But the Windows open file button. So that one there.
That one?
Yeah.
Right.
Then you can select it, and it will actually. So I think it's that one down there.
That one, yes.
Click open.
Yes.
Shows it. If you then click next, it
right.
automatically populates it.
Good. And I can now go and find the calibration file again, which I'll use the same calibration file. Right. And it's populated that box as well. And I'll now call it Altair. Altair. Okay. You sure? Yeah. Did I really mean to change the calibration? Yeah, I did. I did that on purpose. And that is now supposedly a spectrum of Altair. Now, I know that Altair is an A7B star, so if I want to compare that with whatever it is, P underscore A. Oh, that's because it's a DAT file. Well, it's almost worked. That's pretty close. So I've corrected for the atmospheric response and got a profile for Altair, which is pretty good, given that I'm guessing it's an A7B star. And the corrected spectrum I've calculated for Altair, the blue line, is indeed pretty close to an A7B star. So I would assume if you've been doing this on an unknown star, you'd have got to a pretty accurate representation of its spectrum.
But we still seem to have telluric dips in the blue spectrum, the very long wavelengths. Is that right?
Yes, that's because the spectrum you measure will have telluric lines in it.
Right.
And the spectra, the library spectrum, often don't.
Right.
And the red line is just a spectrum pulled out of the library, which has been corrected for telluric or removed, telluric lines removed. That's why they'll always look different down there, probably.
Telluric removal is quite a complex thing,
Yeah.
and it's a little bit kind of subject to
Yeah.
as much of an art as a science, I think.
Yes, at low resolution spectroscopy, you don't worry about it. If you're using an L high res and really looking at H alpha lines, you'd be starting to worry about your telluric lines in that part of the spectrum and how to get rid of them, because there'll be a lot of them. So it's most of the science is in the bluer part of the spectrum anyway. There's not much useful science here. It's H, just above H alpha and down is where most people are interested in recording the spectrum.
I've missed a trick.
Yeah.
Somewhere along the line. We divided our measured spectrum by a reference spectrum,
Right.
and then smoothed it.
Yes.
And is that to calibrate for to adjust out the spectral response of the lamp and the instrument?
No, the spectral response of the
flash and the.
No, it's the spectral response of two things: the atmosphere, which has sucked out some light as it came through, your telescope, your spectrograph, and your camera, all of which change the final light profile it gets onto the CCD chip and read out. So it's correcting for all of those.
I think what you see here is tellurics and the general atmospheric extinction are different factors. So what this does is it corrects for general extinction of the spectrum, not for the telluric absorption lines.
All right.
Yeah.
If we didn't smooth, then it would make some attempt with the telluric lines, but probably
It
get
would
it
go
wrong.
very badly wrong, I think.
Yeah, the response curve fitting that smooth curve, if you leave the telluric lines there, it puts in a much higher frequency element in that line, which tend to screw up the rest of it as well.
Yes, because you could see the
Yeah.
lower range.
Yes, it would be trying to follow all of those lines everywhere in the spectrum, and you don't want it to do that. So that's why you just cut them out. Because, but what the real effect is things like Rayleigh scattering and aerosol absorption in the atmosphere is what's causing an effect right across the spectrum. There's a lot of complexity in there which you don't really want to know it, but we can dig as deep as you want.
David, with 15 minutes to go, do we want to stop the presentation there and do questions, or shall we have another quick look at the atmospheric?
Run through that once more. Yep.
Which I think, I know a couple of people here, so I'm not sure if anyone else.
Just from the moment when we cropped the spectrum from the weird spectrum that we mixed it up.
Yeah. You want that? Okay, so we go back to Vega. Okay. So, starting off here, we've done our smiles and our tilts and all of that. We've got the right wavelength in there. We've decided, well, for this example, I'm going to use the Alpi file mode. So go back to there, go to go, click that. Yeah, it checks this. Are you sure? Because you've got file names which have changed. Are you really? Did you mean to do that? Yes, we did mean to do that. And display profile. We have that profile. Okay. No, we don't. That's the correct profile. That's because, sorry, I'm being stupid. I hadn't taken out the response file at that point. We don't know the response file at this point. So we're going to process not having corrected for atmospheric response, and we get that file, which has got this weird problem with a very low part of the spectrum that we didn't want to process, we didn't want to know about. We've now got our atmospheric distorted spectrum of Vega. We go to response. We ask it to select a reference spectrum. Okay?
So it's response, is it?
Yep, response. Because you're going to calculate the response. We're going to use the Pickles library here, A0V spectrum, which is the spectrum of Vega. Select that. That puts it in there. We now hit response. The green is the raw spectrum we started with. The red one is the library one. The blue one, which has gone off scale, I mean, we could put that on scale, I guess, by increasing the up threshold if we wanted to. We don't actually need to do that, because when we actually hit the response button, what it does is hit the OK button. Goodness gracious me, no idea what that was. We now get a raw response file. If we go to Continuum, you only get that funny error message the first time you run it, for some reason, I don't know what. You can now, just with the cursor, smooth over the telluric lines. Let's not bother about the rest of it, but just use the slide. You can see if I slide the slider up and move it down, I get a closer and closer match to the part of the spectrum. And if I go too far, it follows the whole thing perfectly. I don't want that. I want it to just do a good job of smoothing it. This is the subjective step of the whole process, and it's something you want to take a bit of care to get right. If there are any big lines that are distorting it, just smooth them over, like this one here. If I smooth it over before I do it, I'll take out that little wiggle in the spectrum, and maybe this one too. Yeah, that one I wouldn't be happy about. Okay, I think I'm happy with that, so I say okay. And I save that, give it a name response, save it. And,
so you want to save it with the normalize?
Just hit save.
Oh, sorry.
Save. And then you type a name in, call it what you like. I called it response. Yep.
The atmospheric absorption to cut those out
Yes.
before you smooth.
Yes.
The option on the right.
You would just be using the continuum function to just double click, just click across. If you click on one side of the line, click on the other side of the line, it will just draw a blue line through them. It will, or red line, I can't remember what colour. But it, no. Okay.
Continuum dialog box open.
Yeah, let me reverse this, go back again. Crop. Apply the crop. Do a response. Okay. We got to this point. Now continuum. Okay. So I just put the cursor there, double click on either side of the bits we want to remove. Might do the same on this one. Maybe on this one. You can even do this big dip here if you want. every time you do a manual process, you're slightly distorting it, so you don't want to do it too badly. But then just click, adjust the slider to give you what you think is a smooth profile that doesn't pick up any of the little wiggles in the spectrum. Okay? Then you click OK. And you're left with that. You go to save in the top right. Save that file. Go back to general. Type in instrument responsivity, your response profile. Go back to go. Click go again. The job's done. It's that the very last step is so quick that, that's what makes, I think, the power of ISIS, is in just giving you a final spectrum like that. And you can run the compare process. We said it was an A not B, and I'll bump that up to 6 again, the threshold.
Are all those spectra actually in ISIS?
Yeah.
So
These are all out of what's called the Pickles library. That's all here in the ISIS data store, or database that you download. I did an even better job of smoothing it, because you could see the match of the two are even better on that one. See, that's what the quality of the fit at the blue end really depends quite crucially on how you smooth that response, because there's a high rate of change in the raw response curve, which you're trying to smooth out manually. Yeah. So you manually type in. Yeah. Where it goes in loops is there. Where you've typed in that settings tab. Yeah. Well, because yeah. No, the queue.
I've got the same file. In settings, I've got the same file.
Yes. If you go through the process of using the response command and select the Pickles library and then do select, it knows to go in the ISIS database. If you want to use a different response curve, you can use that ... box. That's a manual override. You say, I know better. I don't want you to use the one that was in the library. I want you to use a different one. You can do it.
So it's correctly found.